Yeah, I'm really excited to talk about this topic today and to close that first day of the conference. More than happy to do that. First of all, maybe a question, maybe raise your hands, who is today already using microservices in production in the room? And now all the other ones, who's planning to do it? All right. So before I start, a little bit on, just brief on myself. So when I started coding, it was actually in PHP back then. Yeah, so that's how I came to coding. Then I decided to go to university in Münster. In spare time, actually like to play tennis, and then decided to start my job joining DHL. And after actually 4 years, I was a little bit tired of doing PowerPoint IT only, and so I was happy enough to go back to code, write a product, build a product together, and I'm more than happy today. We have a team of 50 people in our company where we can build something real, and I think this is what's all about also in this conference, building real things and advancing what we all do. So just briefly on us, so we're a software as a service company based in Bonn and Boston. Today we're 50 employees. We serve around 120 customers worldwide with our solution. And so what is actually what we're doing? We're providing a solution for those companies in order to get an overview of their IT. So this is probably something which we in our early jobs have heard every day. So it's really hard to get to know what is running out there, how is it all connected, to drill it down. So what we usually experience is a lot of Excel sheets floating around, and so that's how we started 6 years ago and wanted to change this world. When we started it was really like a bootstrapping approach. As said before, very classically, we started on a LAMP stack, and it was not only from technology-wise, it was bootstrapping, it was also from the company. So there was no money for the first 3 years. We were only like 3 people in the company, 2 developers building it, and so it felt after like 3 years all a bit, getting a bit dangerous, dealing with those companies, working with that platform, so running around that hill with that box. So we took the decision, like more than 2 years now ago, or 3 years ago, to actually restart our whole architecture, our own. And so this is a bit the journey I would like to take you, and use the next couple of minutes to share some insights on that. So we've gone through that journey more than 2 years, or almost 3 years. So it's pretty hard to squeeze that all in 20 minutes. Well, what I try to do is give some insights more on the what have we learned from an organizational perspective, but also from a technology perspective, what has helped us. So within that journey, we went from 10 customers to now more than 120 customers. We started with 2 developers, now we're 15 developers. The most significant change in our model was actually, we started with a fixed data model, so customers could not change anything in our platform, and we wanted to make that flexible, so that was a big change, but there was something in between as well. So we really followed the MVP approach, so we quickly built the first product in PHP, so it was all hacked together, and it was running for a long time. Actually, it's still running for one purpose. And the key thing was to make it enterprise ready. So we were facing topics like single sign-on, reliability. Customers needed to put in their own credential systems. We wanted to have webhooks and all that stuff. So we had a lot of requirements coming in which were no longer suitable for our original approach. And so that's why we also switched to really like an API-first model from our original architecture. So as said before, so what I'd like to do is to share a little bit what was essential for us as a company, how we build it, so that's more the technical part, and also share some insights on what we learned. And I'm more than happy to answer questions in the ending, what you are facing during your things.
Sorry guys, I forgot to say, use the app to ask your questions anytime, okay? Sorry.
So when we started this journey, I can share one thing which was super critical for us. And you see it here on this timely view. So you see, we started in 2012, and when we started and built this first version, we called it version 3. So we built this. So we started with 1, yeah. But we ended with 3, yeah. So we didn't make it further than that, actually, with that version. And within that version, like I said before, we hacked it together pretty quickly, and then we're growing it. And you see below the team size of the entire company. So until the 4th year, we were pretty much 3 employees in the company. And then we were so lucky to convince large customers, win investors to believe in us. So we were able to grow the team to 15 people. And we always thought, okay, when is the right point to change our architecture? And what we decided was in 2015, not to start changing it in that year, but what we started is building first services around our core product. So that's when we started the version 4 bootstrapping, kind of building services which were not so critical, but selecting the target platform already. And what was for us essential is to have that team which we were building, a bunch of developers coming on board, needing to understand what we're really doing. So we worked on the original product, what we called here maintain, for more than 12 months. Yeah? So it was really critical to understand what we are doing in our product and why we're doing it. And in parallel, we were trying out those technologies. And then in 2016, we kicked off a project which we called internally Pathfinder, and I will say something about this in a second. And then in 2017, we actually migrated all customers while getting new customers on board. And so I can only emphasize for every young company, if you would want to go to a new architecture, make sure your team is experienced in what you have done before, at least in the functional way, so that you understand what the product is. So still today, we struggle with that, that not everyone knows in all areas, but this was, I think, an important factor for us. I talked about this wording Pathfinder. So what we actually did is we gave this child a name, and we selected a name which was one of the most successful missions of the NASA. So it was the cheapest mission they had, but the most successful. And we thought at that time, being like a couple of people only would be a good mission. So that created some spirit also in our company. So we always knew what we were talking about. So it was not like a development thing only. It was more like everyone in the company had an understanding what we were doing there. One very important thing we decided early on was that at every time we were building the new thing, we would be able to show customers how it worked in the new version. And you see here behind me the version 3 of our product on the left-hand side and the version 4, which we call Pathfinder. So whenever we had a new version which we built, the customer could kind of ask us to click on a button, and we could upload the new data in that workspace. So that's what we used throughout the whole phase to always understand how would the new product actually work with it, and how customers give us feedback on the new version. And I think we screwed up a lot, so in this migration. So if you ask our customers, so they will say a lot of war stories. But overall, I think they told us that they understood when we were doing this process, what we were doing, features were coming on board, so they were able to test them out early on in this environment. So that was a pretty crucial thing, which I can just recommend, build it into your process. If you need to migrate data, which we had to, that you allow customers to early on try it out. So they just had to switch to /beta in their browsers, and they could see the new product. Then you saw this time which we called migrate, that at a certain point of time we started to shift new customers onto the new version. And what actually happened is early on in the days we were thinking we were agile, so we were not. So we switched to Scrum. So the whole team in the first year actually got a good understanding how we do this. But during the migration we found out if we stick to Scrum, everyone would either leave the company or we would have no customer in the end. So it was really painful, because we stood up in the morning, and Niklas is here also in the room, who helped me a lot during that time, making sure we prioritized the right things. And every morning the world was different, because at the day before we had to migrate a customer, and then we found out that data migration didn't work out, so we had to find a new idea. So eventually we took the decision to say that's no longer possible with Scrum, what we're doing here. We need to move the whole thing to Kanban. So what actually happened is we created, and this is really the picture from the room. So every morning, 30 minutes, we sat together in a room with our, what we call customer success department, who are really the interface to our customers. And so we kind of created that matrix here on the wall, which always had like the most important things on top and the others on the bottom. So you might be able to guess the yellow stickers are actually features, the red ones are bugs. And the annoying thing for us was really the features here were not new features. It was just rebuilding parts of the old platform and making sure the old features still work. So essentially, during all that time, it was always like either you had a bug or something which didn't work of the old version. So, and that what went on kind of for 6 months while we were doing this migration. What was good during that time, we structured it in a way that the customers who didn't require a lot of features, and we analyzed it by the usage, we did them first in the migration, and then, of course, the more complicated customers later on. That has actually helped a lot in this whole process. What I can tell is it's a very tough journey. So that's actually the day when we completed the migration. That was like the last customer moved over to the new platform, and we have a habit in the company. So whenever we close a customer, we ring a bell. Yeah. So that was really the event. The engineering team was ringing the bell, and I think for us as a company, growing that fast during that time, it was always like the challenge, will we survive it in terms of deciding not giving new features to the existing customers, but still working on the new ones. So there was a certain pressure on the whole team. And what I definitely can recommend is there needs to be a good morale during the whole period, and of course also celebrating that success is pretty important. So I think everyone in our company recognized what the engineering team has built and achieved during that time. So these are a couple of things which were essential from an organizational perspective. So I'm not giving you like any methods or tools on how to do that, but some aspects which I found I would do this again actually. In terms of technology side, there are a couple of things we had to do, which we required to do this journey. So this is actually showing how our transition looked like. So in the first years, our platform was really like a classical MVC application. You see it on the left-hand side. It had a database and the technology said before. And today, it's pretty much what it looks on the right-hand side. It's a single-page application running on latest or on Angular 4. We're upgrading it soon to the latest version of Angular. And then in the back end, we have all separate services having their isolated databases. So it's in the back end service, all Java stack. We're running it on a drop wizard. And then we use different data stores, PostgreSQL, Elasticsearch, Kafka, and ArangoDB for different purposes. So this is how our architecture actually looked like. What we always did during that time was we already ran our old platform based on Docker. And while we were building the first services in our new platform, we were running it side by side. That means we deployed the whole thing in Docker containers, each of the servers, each of the resources. So we had already some experience over the time what it meant to deploy this platform and to run it in production. And so what's actually happening now is we were able now to switch off more and more of the left-hand side, so that only the new architecture actually survives. There's one principle which we follow. I would say it's actually more or less industry practice right now. So if there's a REST API not documented in Swagger, something is broken. So that's what I believe. And I think that's quite common. So whenever we have a REST API, we have a URL where you can go to as a developer, as a customer, and you get the Swagger documentation. So we ship that. You see that on the left-hand side. You get an interactive documentation for those who don't know it, and you can actually add your API token, kind of your credentials, try the API out. and also generate an SDK from it in different programming languages. So this was what we early on decided, and actually is there for all our APIs, so that part is kind of automatically documented. There's one thing which we decided early on, which allowed us to build more and more services over the time. That was we were using OAuth 2, and we had a talk, I think, today covering this topic. But what we did is we decided to combine it with Jwt Tokens. So I'm not sure who has heard of that, but Jwt is a mechanism which allows you to distribute, so to validate tokens in a distributed way. So what we wanted to avoid is that whenever there's a request to one microservice, we didn't want that that service needed to authenticate again to a single point, which could be a failure then in the end. So what happens is, using that standard, we are using OAuth with Jwt tokens, and all our services can validate those tokens on their own. And so what you actually see also in this example on the right-hand side, we also put some payload into those tokens. So for example, the role a certain user has, or the permissions he has, or which account it's on, so that the idea is our services can on their own validate this information and actually also extract required data for the usage of those services. The validation takes part with normal public-private certificates, which we deploy to those services. And I think this has really been very important for us in our structure of building more and more services in the end. There's one thing, while I would still say REST API is like standard, you need to do it. We found out in our journey that we have limitations with our REST API. So our tool is actually built around visualizing things. So this is, for example, a map of applications we show to our customers, and this map requires different resources to pull out of our microservices. And so the issue is with REST, what you can see here on the right-hand side, you would have a couple of requests going back and forth to the server. And the other thing is actually you increase the payload because in order to generate this visualization in the browser, I don't need everything from that resource. I only need certain attributes. Unfortunately, every report or every view again needs different attributes. So instead of ending up with a whole set of different endpoints, or with a lot of customizing of those endpoints, sending the attributes which you want to have. So what we came across, or actually the team came across, which was even better, they found out at that time that GraphQL is actually the right solution for our problem. So what we are using, and for a certain part of application, we use GraphQL as our API. So for those of you who don't know it, it's actually, for me, it's something like SQL for APIs. And you see an example query on the right-hand side. We were able to query the exact same thing what we had in the picture before in one query, and only requesting those attributes which we really needed. So here you see the red ones. So if you imagine querying a REST API, a traditional one, you get a lot of payload you don't need, and you ship it over the wire, and with GraphQL you explicitly say what you want to have. That was the one aspect which I think holds true for many applications where I've seen the issue that some of the requests are actually very inefficient. There's another aspect for our solution. So I said before, we were using a strict data model, and now we were using a flexible data model. So our customers can adjust the data model very, very, in a very comprehensive way, can change a lot. But the result would be you only have a very generic REST API. And this is what we wanted to avoid. So in our case, what happens is the customer can change the data model, and he still gets a strongly typed API via GraphQL. And this is a huge advantage for us. So this could be a side effect for applications you're building. Whenever you have something generic you build, take the advantage of GraphQL and generate the schema on the fly. So because anyways, the schema needs to be generated by you. So this is a very handy version of providing flexible data models to customers. Another key point for us was, if we would go this route of moving everything to a microservice landscape, we put a lot of effort in our operations, in our operation setup. So one thing we early on established is actually green-blue deployment. So what it does is the following. So in our case, we have a load balancer sitting in front of our services. So it's Nginx in our case. And it's routing the traffic to our containers, which are currently active. So in this case, service ABC, always in the version 1.0. And those services actually access their databases. So what happens, or how we do it, so we deploy using Jenkins. We call Ansible, a language which automates all our deployments and our server provisionings. So Ansible ensures that Docker containers are created and spun up, and those Docker containers register in etcd and put the required information then in Nginx. So you all might say, okay, I'm tired of this, so Kubernetes all does this for me. Yeah? Our issue was we did it 3 years ago, so at that time, so we couldn't rely, unfortunately, on something like Kubernetes. So we had to build something on our own, but we really need to establish this in early on, so in order to make it work. So what happens is, if you now deploy new services, service ABC, all in the next version, 1.1. So they're getting started on our server. And what we can actually do is, we can, with a special token, we can access those services. So in production, we have access to it and can see if they work. So that's the theory. Unfortunately, we never made use of that functionality. Yeah, so that's the bad news. Yeah, so it's possible, but more due to, let's say, organizational things, we never actually made use of it. Yeah, so that's one of the learnings. Sometimes you also overbuild things and over-engineer things you end up not using. So I guess we also have some engineers not even knowing that we can do it. But that's actually the theory. What it helps us is then to switch in a second. That means we can deploy all the time. So that's why that's what green-blue deployment is also made for. So we don't have actually any downtime for it, and we allow customers then to reload their application if something is needed or changed in the front end. So this was very essential to us in our deployment setup. There's one thing connected to it, which is probably always asked, so how about database migrations? So how do you deal with that? The one thing is, what we use Liquibase for database migrations in our relational database, PostgreSQL. So I would say this is rather the easy part. The harder part is if you use Elasticsearch as a storage for search, which we do. You cannot easily change the meta model of Elasticsearch on the fly. And so before we started, so we thought, okay, can we always deal with building the new meta model, so having a maintenance or downtime for that? And we said, no, not possible at all, because we want to iterate fast, deploy very often, so sometimes a couple of times a day. So that's what we try to do, at least a couple of times in the week. So we cannot afford that we always need to have someone changing the schema on the weekend and rebuilding it. So what we did is we've built something which allows us to rebuild the schema in Elasticsearch on the fly. So originally we have one side which of the schema which runs on our green container, which is still in production. And what's happening then? We are deploying a new version of the product, and then this one starts creating the new schema. So in how we do that, we do that fully event-based. That means we replicate a new schema into the new version, and then we use Kafka to actually stream through all the events which are coming in order to make sure that in the end, after this whole process is done, that both schemas are still in sync with the data which is actually coming in. So for us, this was a crucial thing to think about early on. If you're going through that migration, try not to rely on any maintenances or downtimes, because you will do mistakes, you will need to correct them, you will need to correct them fast. So you can't say, okay, on Wednesday I discovered a critical bug and then I wait until Saturday until I can do a maintenance window. So not possible at all. So I think that was actually very important for us to build in such a logic. I'm more than happy to chat if there's someone who has built a better logic or found out how you do it. But it works well for us, and it's pretty robust in production, actually. So another thing which was actually really, really important for us is to create a very good operations toolchain. So in our case, what we do is we do monitoring of our instances using New Relic for more the server level information like CPU, memory, or errors on server level. And then we use, in every service which we've built, we've put in a health check. So every service does like a self-diagnosis and saying, okay, I'm healthy, I can reach the database, I can process events, I can send out things. So that is what we discover with Pingdom. Yeah? So we check those services every minute to see if they're still healthy. And then we also get logged files into log entries. We collect all that stuff into PagerDuty, and then from there, it actually allows us to create alerts. There's one thing we also integrated in our toolchain, which is whenever we have customer issues which come in through Zendesk, we get them into PagerDuty as well. So it's not only that if a server is unhealthy, but also if a customer says, okay, you are unhealthy, it also goes into our alerting system. And from there, it actually goes into different kind of channels, into a Slack channel on mobile phones, and also, if needed, on our status page, which we use to publish our status. So for us, again, this toolchain is crucial, so you have it in place. So you might say, okay, this guy wanted to talk about microservices. Why is he now talking about operations? Yeah? So I can only say you need to have that in place. I wouldn't say we're like really, really good in it already, but if we would not have this in place, we would completely screw it up every day. Yeah? So there would be no chance to operate our platform. We have this Gecko board, so like a dashboard in our office, which we look on. Yeah? So we sometimes get heart attacks if it gets red, yeah? And we have not seen it before in our Slack channel. But this setup is actually pretty important for us. What did we learn during this path? So this sounds a little bit like, okay, sounds all good, yeah. We took the right decisions. There were a couple of things which we learned during that time. So the most important learning is you are not Netflix, yeah? And we are not Netflix, and so you find a lot of good information on how you cut services, which tools you need. In our case, it's actually a very simple equation for us, how many microservices you have in the end. It's definitely lower than the number of developers you have. So if it's the other way around, I can only say there's a mistake, because we were there. In the beginning, we had more microservices than developers, so there was something wrong. Even if you could say, in theory, it sounds right, it's cut small enough, but you are not capable of maintaining all different services at the same time. At least in our world or in the setup we are running. So for us, and this is Adrian Cockcroft, who originally built a lot of stuff at Netflix, a lot of great stuff. So for us, we adjusted a little bit the definition. So for us, it's every service has an API, so that's important for us. Every service is documented using Swagger. We have no shared databases, so nothing goes across those services. It's not one function or one thing. For us, it's more one concern, so one area of functionality which we have in a service. It's containerized, so we can deploy it easily as a single container using Docker with one process in Docker, and the service is configured using environment variables, very, very close to what the 12-factor app is recommending. So that's what we right now consider as a microservice definition for us, and probably we will evolve on that in the future. There's one other thing in our setup which is crucial, you need to frequently look at APM, so application performance monitoring. Because in our world, it was even a bigger change in terms of technology. We shifted from a model where each request created a new process or a new thread. Yeah? So we were using on PHP, for those who can still remember how PHP works. Yeah? So it's usually creating requests, and after the request, it's gone. So we switched to more stateful model. Yeah? So running Java microservices where you have a process running, and so easily we built things which were eating up memory. It's also not tightly related to microservices, but as you do the journey, you might come across this. So for us, having this always in mind is a very crucial thing. One thing we also learned is that establishing team ownership is very important, and we probably did it a little bit too late in our process. So this is the map of our services and also the underlying resources. And the different color codes are actually the different teams we have today. So right now, we already achieved to have like a good cut of services to teams. So you see it here, webhooks, integrations, and SyncLog are services which are maintained or owned by the team Flow, while we have the green ones are maintained by the team Invent, and so on. So we have clear cuts in some areas, but we also have like shaded cuts in other areas. So this is what makes our life today complicated. Yeah? So where you see on top, different areas of this one service maintained by different teams. So this is something we actually could have established a little bit earlier on to assign this. But afterwards you're always more clever. There's one thing for me in a microservices world, the deployment is the new monolith. Yeah, so so now you're happy, you got everything away. Yeah, so you have now the services, and now the whole logic is in the deployment. And that's why my recommendation would actually be focus a lot on automation and always try to improve that. Our team actually built a whole release tool around it, which allows us to quickly release new services. We use Ansible a lot. We're currently migrating our infrastructure to Kubernetes, and therefore I can only recommend start this journey early on. If you really want to go to microservices, you need to have that in place. Otherwise, it's getting very hard. So there's something, we're from Bonn, where Carnival is big, so it's always, don't forget the fun in such a journey. So on the right-hand side, that's actually our VP Customer Success, so he has dealt with the customers, so he is wearing a NASA suit, so even after all that time dealing with all the pains, so he still was happy about our project. So overall, we were pretty happy to get this done. Thanks a lot.
Amazing. Thank you. We have some questions. I'm not going to waste time saying anything. We're going to get straight into the questions because we have some good ones. Drink some water.
Yeah, that's okay.
I'm really grateful for this insight into how a company actually does it. I think we all learned something. Keep the noise down as you leave, please. So what about transactions crossing multiple services?
Yeah, so definitely not an easy one. So I think the whole topic has different angles. So the one angle is probably one important one. How do you see if you call multiple services in the back end, even in logging? So one thing which I think is a common pattern to add unique logging IDs, so which go across the requests. So that's something we have in some areas, but not in all areas. So definitely something you need to have. In our case, we designed the services around it that as much as possible, we're not getting those conflicts, but we have it, for example, in areas where you first need to create something, then afterwards you can do something, and then you always need to implement such a rollback logic in one area. So definitely not an easy topic. We probably not have a full answer to that, except that we try to cut it in a way that we limit the number of those transactions.
Thanks. Let's press on. Now, I mean, you touched on this earlier, but I mean, it says here, did you decide on microservices because of organizational or technological reasons? It's like a bit of cat and mouse, isn't it?
Yeah. So, well, at that time, so I think for us, so we're not, as I said before, so don't think you're Netflix. We're also not Netflix. So it's not that we have 1,000 developers and you need microservices and you can't run without it. For us, it was something like in between. We had the issue, not a team. I don't think a team of 15 people can work on one code base and work on it efficiently. But also we got requirements. We get requirements all the time from big companies. And if you put them always in the same thing, you're limited in the choice of technologies. Yeah. So I think that was.
So there's a third factor in there, though. You've got organizational and technological, but you've also got the customer, because the customer was pulling.
Yeah, exactly. And I think we're in a B2B business, and you get not only functional requirements, but we had to implement SSO, so allowing our customers to connect to a platform without password. And that was actually the trigger when we built the first service, because we said if we need to implement this capability in our existing code base, it might end up as a nightmare. So we decided to build the first service for that. So
I get this impression of someone who just sailed around the world, but in a ship he built on the way around the world. Yeah?
Yeah.
Okay. What about deleting data in multiple microservices?
Yeah.
Good question.
So one thing I didn't show here, probably you all heard this scary term GDPR. Yeah,
it's further. It's on the list.
It's over there. That's okay. So it's all affecting us soon. Yeah. So we all need to take care that we delete data in a proper way. So what we do is we have an event structure. So we call that service webhooks. It receives events from all our other services. So whenever something is deleted or created, so for example, a workspace, that event is populated into our service webhooks and other services can subscribe. So we have areas where we already subscribe to that event, and then other services actually know they need to delete something. Yeah? We have other areas where we will use this mechanism to do it. So what we want to avoid in our architecture is like creating spaghetti. So if you delete something here, then you call it in the other service to delete it there. So if you end up there, you would be better up building a monolith. Yeah, then don't do a microservice architecture.
But does that mean that, I mean, we talk about GDPR, but does that, somebody said to me, listen, GDPR is just good data hygiene. You should have been doing this already. So GDPR is just Europe saying, come on, guys. And you get all these emails saying, Twitter takes your security seriously. Bullshit. The European Union does it. Sorry, that's my rant. That's my rant over. Yeah, man. I never thought I'd get applause for mentioning the European Union. But okay, so deletion, we've done that. Thanks, Stefan. Front-end monolith. Can you say something about that?
Yeah, well observed. So if you remember the picture where we have the single-page app on top of all our microservices, yes, that's the monolith, and that's creating a certain amount of trouble, I would say. It's already better than or much better than what we had before because it has modules, it has areas, but we are definitely thinking of cutting that in different areas by the functionality. So for example, we have a survey functionality, which allows us to, so it's just like SurveyMonkey for our use case, and it's built into the whole other front-end application. So we could have built it into an own front-end and put it in front. In our case, we wanted to ensure first that in our migration to Angular, we have a consistent way of building an application. So eventually, we might carve out things from the front-end application again.
Let me just squeeze a question in, because I think it's interesting for all the developers in the room as a takeaway, what they can take away from this. You've given us a real insight into someone who's done it. What would you say? What are the 3 websites that people should look at now to learn more about this, to take this and try it, to practice?
Yeah, so what I referred to before, the 12-factor app, so that's probably one of the sources which is pretty important. Definitely, but this is more like, let's say, the theory part, Martin Fowler, giving always good insight on that. And if you want to look far ahead, then although I said you're not Netflix, you can learn a lot from them.
Yeah.
The Netflix OSS, which gives a lot of libraries and tools for dealing with microservices, and you will notice, shit, we already built it on our own. There was something they already thought about. Yeah, so I think these three would be recommended on different levels: theory, practical, and aspiration. Yeah.
We're over time, but if you're listening, he's answering. Okay. What about this top one here? What about messaging brokers like RabbitMQ? That means nothing to me.
Yeah. So we used RabbitMQ actually in our old product as a message queue. It's like a normal message queue system. What we have found out that Kafka fits our needs much better. So today our communication layer is probably something which we build around Kafka. And so the key difference for us is with Kafka you can ensure that it's really sequential. With RabbitMQ you can kind of build something around, but it's not really made for it. Yeah? So what we also needed is we wanted to have like fast storage in it. So that's all things Kafka brings for us. So that's why we actually.
But by the nature of the microservices, you're integrating with lots of different frameworks and products at the same time. Do you have to like continuously audit them to make sure they do what they say they do?
Audit or update?
Both.
Yeah. So I think the update thing is creating also a lot of headache. Yeah? So there might be another equation which says the number of technologies you're using must not be larger than developers divided by X. Yeah? I don't know. So hopefully you also have a better gut feel about this. But definitely the more technologies you have, you need to take care.
That's like question 3 there. How many microservices do you have right now? That's curiosity. How many do you have?
Yeah. So if I count on this slide, it's something like 8.
Okay.
8 or 9.
And you feel happy with that with the people in house?
Yeah, so that's or 8 or 9. So that's the number which works well. So because you see now in this picture which was colored that some teams have like 3 microservices they deal with, and our team size is now something like 4 people. Yeah, now growing to 5. I think that's a healthy number.
I think André is very modest. I mean, obviously there are some brains behind this. It's not just technology. Somebody is navigating through this with caution and risk and fun, or curiosity. Is that right?
Yeah, absolutely.
I mean, yeah,
so it's not, you cannot all.
I'm using your time now. Yeah. I can stay here all evening. Yeah. One more. Who decides? I mean, come on. What else do we have here? Stefan, delete a couple of questions. Yeah, that one. I like the one with the beta. When do you go beta with your customers?
Yeah, so what I didn't tell in the story actually was the first user of the product was actually a very cutting-edge technology company, which is our customer. They were actually the first customer. And we were very openly discussing it with them. So they said they want to use our API. We said, look, if you really want, then feel free. So we had a very good relationship, but they were a very demanding customer. So I think that was very, very early on. But we also onboarded another customer, a huge automotive supplier, which used the platform early on. And that was also very, very early in beta. But we always communicated with them and said, so we always had a list of things which were not working in the product. So we gave them that list. Yeah,
sure, so behind the scenes, you also have very good relations and relationship management with these customers. Yeah, so that's the picture I was showing of Christian in this suit. Yeah, so he had to face all the complaints, all the things. Yeah, so there's really like a tough exchange also sometimes. I'm going to wrap it up here because otherwise there won't be enough people to give André the applause he needs to have for everything he shared with us. Thank you very much. Cheers, André. Thank you. Thank you very much.